Okay, we are going to look at reactions of alkenes, and then there are two categories. One is called combustion, the other one is addition. So first let's look at combustion. Combustion is simply burning the organic matter with help of oxygen. So there are two kinds of combustion. It's either complete or incomplete. Incomplete, you produce CO2 and H2O. In incomplete, you produce carbon monoxide and H2O. So you always produce H2O. You also always produce heat, whether it's complete or incomplete. The only difference is carbon monoxide versus carbon dioxide. For the example of combustion, I took butene, C4H8. Now, if I say it's complete, you should produce CO2, so 4 C's will give you 4 CO2. 8 H's will give you 4 H2O's, half as much. Then look at the oxygen. You have 4 here, and you have 8 here. 8 and 4 is 12. Divide by 2, so you need 6 oxygen. That's complete combustion because I produce CO2. For incomplete, the same molecule butene. This time I produce CO, carbon monoxide, 4C, 4CO. 8 H's will give me 4 H2O. Now I have 4 hydrogen here, oxygen here, and 4 here. That's 8. 8 divided by 2, I need 4. If you look at the 4 versus 6, this shows you didn't have enough oxygen, and that's why you produce carbon monoxide. So in incomplete, we do not have enough oxygen, and carbon monoxide is produced. The next category of reaction are called addition. What happens is in alkene you have 2 bonds between carbons, and one of these bonds can open up, so 1 electron goes here, 1 electron goes to other carbon. Then you can add atoms to it. So if you have X2, if you have X and X, one X goes on the first carbon and the other X goes on the second one. Now what happens, alkene, which is unsaturated, becomes saturated alkene. What are these things that we can add? So it could be H and H, hydrogen, H2, diatomic gas. It's addition, but you can call it hydrogenation. You could also add a halogen like bromine, chlorine, or iodine. So you call it halogenation or bromination. And you can add H2O, but when you look at H2O, you should consider it as H and OH as 2 sort of different parts. And this simply is called hydration. You could also add binary acids like HBr, HCl, HI. Let's look at each example. So first I'm going to do hydrogenation. I'm taking propene as example. So propene has one of the double bonds is going to open up. And then I'm ready to add 1 hydrogen to each. And if you do that, propene becomes propane, so you simply saturated it. Alkene became alkane. The next example, I'm doing the same thing for propene, and I'm this time adding bromine, diatomic halogen bromine. So what happens to one carbon, I add bromine, to other one, I also add bromine. Pay attention, each of the carbons will take 1 bromine. And the name becomes 1,2-dibromopropane. So now you became saturated, and you have 2 halogens added to it. Example of hydration. Hydration produces a new organic family known as alcohols. Alcohols always have OH or hydroxyl as their sort of characteristics, and it's called functional group. I go after propene one more time, it opens up. Now you're ready to add H and OH. But 2 possible products come to life. One is you can add the H to the carbon at very end, which I did, and the OH will be added to other carbon. And if you do that, it becomes 2-propanol or prop2ol. And it's a major isomer, it's about 99%. Why is the case? Because it seems from practice hydrogen has tendency to go to the carbon with most hydrogen. But then we are also giving you the minor isomer, which is that the H went to the first carbon inside and the OH went to the carbon at the end. If you do this, then you have one propanol or prop-1-ol. So we have two isomers or two products. One is major and the other one is minor. So you can remember this, that hydrogen is added to the carbon with most hydrogens to have the most isomer being produced, or major. Same mentality happens when you add acid to it, a binary acid such as HCl. Now the propene opens up again. The H could be added to the last carbon, which is the tendency, and the Cl could be added to the carbon with less hydrogen. And that's the major product, 99%. What should I call it? It's on carbon number 2, so it's 2-chloropropane. The other possibility is that the H can go to the carbon with less hydrogen, and the chlorine can go to the carbon with the more hydrogen. So it's the next isomer, and it's 1-chloropropane, but it's only about 1%, or minor product. So pay attention to hydration and adding acid, that hydrogen has tendency to go to the carbon with most hydrogens.